Hello, everybody. How's it going? You're not seeing my face because I am very sick. You don't want to see what's going on my face today. So as always, we have
I see it. You don't want to see that.
you're still seeing me? Oh my god, I gotta do something about that. I thought I'm good. But no, we can't have you see me. There we go. All right. So now nobody sees me. Hi, Leandro. How you doing?
Hello, Arya. I don't even have to ask how you are doing because I know you're not doing well.
Yeah. I'm sick. I never get sick, but when I do, I know that it's a big it's a hefty virus or whatever it is because I don't get sick. I always rolled around in dirt as a kid and then rolled around in the mud as an adult all over the world. So yeah. So when I get sick, it's like, oh boy, it's gonna hurt. Anyhow, yes, we're gonna be scripting today. And
Yes.
last time we left, we had this situation, but it was not super. In fact, I can show you exactly what it looked like before, just so we are all on the side. I think it's this one. Yeah. So
Yeah.
last we talked, our thing looked like this. Still not bad, you know. But now it looks like this. Zoop, zoop.
Yes, I did my homework and I figured out what the issue was. Well, not exactly. I didn't figure out what the issue was, but I solved it.
Okay. Yes. When you say that you didn't exactly solve it, meaning like you're not sure why the code how you wrote it wasn't working, so you just gave up and you said
Yeah.
okay, let me.
We were working on this idea of using the equations of motion to come up with a path, and then I thought about fixing that, but then I realized that there is something even simpler that we can do. Instead of using the equations of motion, we can just simulate what's going on. We know that, for instance, acceleration, what is the meaning of acceleration? Do you know what the meaning of acceleration is? The definition of acceleration? Do you know what it is?
Yeah, it's speed over time, right?
Exactly. So acceleration is variation of velocity. And similarly, velocity is variation of position. If you are moving at 5 meters per second, your position is changing 5 meters per second. That's the definition of velocity. So I thought, instead of coming up with all the simplifications of the equations of motion like we were doing, how about I just start with the initial setting? We are letting the ball go, so the initial velocity is 0, and we know the position because that's a slider. So I just start with those, and then I have a loop, and I keep updating the position and the velocity. So that's what I did. I just simulated everything instead of using the equations of motions, and that's what you see on the slider block.
Oh, okay, slider block.
Oh, you don't have the latest version of my code. Can you go to
the
code share thing that I linked to you?
Yes. Zoops. And there it is. I'll bring it over here. I'll make it a normal size.
Well, you can just copy the whole code that is in this.
Cool.
And paste it.
Cool.
In wherever you're going to find it later. I know you have many versions of the effects.
Yeah, in fact, I'm going to do... yeah, I'm going to put it on the one that I have the hotkey for because we're going to constantly be deleting and undeleting. Cool. And save that.
Yeah, so you can go... Oh, yeah, the thing that is on the screen right now at the top...
Sorry, one sec.
Is...
I'm going to do the whole ritual one more time in Shibloings. All right, here we are.
Yeah, and it still looks the same as when we started the stream. Great. So in the slider block, we are updating the position array. So remember that last time we defined this positions array. It's on the screen right now. And we initialize the positions array to be an array of 5,120 positions, because we said that if we have that many positions, it's going to contain enough pixels for a very wide monitor. And then in the slider block, we update this array to contain the positions of where the ball should be over time. And that's the thing that we are eventually going to draw in the JSFX block. So if you look at the last block of code in the slider block, it starts with positions dot, that part. So what I do there is I first define this time increment because, well, the ball is moving somewhere. So there is a notion of time going on there. There is a timeline. So I am going to compute positions of the ball over time. What is my time increment? Am I taking snapshots, or what is my frame rate? Am I taking snapshots every second or every half second? So naturally, the more positions I store, the smoother the movement. And if I store fewer positions, then it will be less work for the computer to do. So that's the trade-off. If I want a smoother line, I have to ask the computer to do more computation. And that's this magic number that is right on the first line of the block, the 20 divided by 1,000 divided by the number of positions in the array. In fact, how did I come up with that number? I played around until it kind of looked nice. That's what I did. So nothing mysterious there. So that's the increment in time. So every time I am computing this positions array, I am moving forward in time by that amount, which is it's a very small number. And then on the next lines, I set up the initial situation. Velocity equals 0. Can you tell me why?
Because we're just dropping the thing. We're not velocity 0 is because that's the first time it hits the ground, right?
No, it's just the initial
that
setting.
is the initial velocity.
That, it's just we are starting the experiment. We are letting the ball go. Its initial velocity is 0. It's not moving when we let it go. Then the position that we are going to keep updating in the loop that we are about to see, but the position of the ball right when we start rolling the camera is whatever is the slider. The position dot initial is a slider that we control, and it tells us how far up the ball is when we let it go. That's that slider right there. Great. So then we start a loop. And in this loop, there is this positions.index variable. It is going to be an index over the positions array. It's a similar structure to what we had many times at this point. Then, in the first line of this array, of this loop, I store the current position. Remember, I have this running variable called position. It starts with position initial. So I'm going to store it in the positions array to render it later in the JSFX block. And then I need to update all my variables. So for instance, velocity is going to be updated. You can see velocity plus equals. And in this case, as we said, acceleration is the change or the rate of change of the velocity. So I am changing velocity by acceleration. But I need to take care of two things in this line. First, the acceleration vector is pointing down towards Earth. And in our coordinate system, in our coordinate system, positions that are positive go up. So we have to say that it's minus acceleration to make the vector of acceleration point down towards Earth.
Did I understand that? I think I did. Okay.
Yeah, so just remember that the desk is position 0. and we are letting the ball go at position like 1 meter.
Yeah.
Right? So the y-axis is positive going up.
Yeah.
But the acceleration of gravity is a vector pointing down. It is pointing towards the center of Earth.
Right.
So we need to say that the acceleration is not 9.8 meters per second, but minus 9.8 meters per second.
Oh, gotcha. So a question
So that's what this is.
here, because we've only ever had this syntax with numbers. So in this case, it works the same way. It's just like this number, or this number more accurately, is calculated and then added to velocity, right?
That's right.
Cool. Okay.
Yep. Another way of writing this is just velocity equals velocity minus acceleration times positions time.
Okay, yeah.
So it's just that. It's just a shorter way, so you don't have to say velocity equals velocity something.
Cool. That's a good way. That's nice.
Yeah, it's exactly the same. In fact, when the compiler sees an equation like that, it is going to interpret that equation as velocity equals velocity plus something. Right. Okay, so that's thing number one. The acceleration needs to point down. The second thing I have to take care of is, well, we have this time increment going on. And remember that acceleration is, for instance, the gravity on Earth is 9.8 meters per second, right?
Yeah.
That's the acceleration. So every second, the velocity is going to go up by 9.8 meters per second.
Yeah.
So we're in this case, we are not working with a time frame of a second. We are working with a time frame of a time increment, which is a very small time frame. So that's why I multiply by positions.time increment. So if I wanted to make the curve smoother, I would decrease the time increment and the velocity would increase by a smaller amount. And we don't have a slider for that.
Mm-hmm.
We don't have a slider for the time increment.
Yeah.
So that's how I update the velocity. Essentially, we do have to take care of like negating the acceleration to make it point downwards, and we have to multiply by the time increment because we are not working with windows of a second. But essentially what we're doing is velocity needs to be updated with respect to acceleration. The next line is similar. This time we turn our attention to the concept of position. And velocity is just the rate of change of the position. If you are moving 9.8 meters per second, it means that every second you are 9.8 meters away from where you started. So velocity is just change of position over time. And that's what I do in this line. I say position plus velocity. I update the position. So I am essentially simulating what the universe would do. I'm saying that now the position is updated or incremented with the current velocity.
And then
I also
max
have to take care
situation. What's that? What's max?
Sure. Yeah. Great question. That's exactly what's next. So we don't want the ball to fall through the desk. That's something that we tried to address with various hacks last time. We don't want the ball to fall through the desk.
Yeah.
So we never, and the desk is at position 0. So we never want the position to be negative, right?
Mm-hmm.
So if you just let the position be updated with the velocity, the position starts at like 1 meter, and then the next frame it's going to be 90 centimeters, and then on the next frame it's going to be 70, and then the next frame is going to be 30, and then on the next frame is going to be minus 10, and then on the next frame is going to be minus 20, and it's just going to fall forever. We saw that last time. It was falling forever.
Yeah.
We just saw one parabola, and it was going down forever. That's not what we want. So what I'm saying there is I want to take the maximum between the updated position. So position plus velocity is the updated position. I want to take the maximum between that and 0. So think about what happens when the updated position is positive. What is the maximum between something like 0.7 and 0?
It will be 0.7. Now I saw this comma. I got how it would like compares these two things and whichever one's bigger. It's going to pick that one, right?
Yeah.
Yeah.
Yeah, exactly. So if you have something like 0.7 and 0, the maximum between them is 0.7. We don't change the updated position. But if we are going below the desk and the updated position is like minus 0.2, what's the maximum between minus 0.2 and 0?
0.
0. So we are saying if the ball is going to try to go through the desk, we are stopping that.
Yeah.
And then on the next line, we need to do some bookkeeping, because if the ball is now at the desk, position equals 0 means the ball is currently on the desk. It's hitting the desk right now. That's a bounce.
Yeah.
In that case, we want to update the velocity vector. Right now it's pointing downwards. The ball is going towards the desk. But now that the ball is bouncing, we need to make the velocity point upwards. That's what the bounce is. It's going to make the ball go up. So we say that velocity is equal to minus velocity. So we're just inverting the direction of the vector. And we are multiplying by elasticity because some of this energy has been lost as sound.
Right.
And the ball is not going to go up as much as it came down before. So if we dropped it from 1 meter, it's only going to go up to like 80 centimeters or something like that. That's what the elasticity is all about. So minus velocity times elasticity is the new velocity vector. And the velocity used to be negative. Now it is positive. So the ball is going to go up and it is going to come back down. And then we are going to hit the desk again and we are going to go again.
By the way, I don't know if I may not have shown you this, because remember you said like when I took the video of dropping the ball, I should have the meter like slow it down so we can see kind of where it goes to. Like so we can read on the meter how much it bounced back up by. So do you want to see that?
Yeah, sure. So I guess we can do it like this. Let me finish explaining what I did to fix the mistake. Essentially, the core of the logic we already went over, but I also want to go to the GFX block just to show how I'm actually drawing the positions.
Okay.
And then we can play around with the sliders that I know you have calibrated some of the sliders. And then we can also look at the video to help calibrate the sliders and everything. And Bo is here. Hey, Bo.
How you doing, Bo? It's going.
It's not well for Arno.
No.
So in the GFX block, we are just going to look at the positions array. We have already calculated all the positions in the slider block. And we do that in the slider block because the positions are not going to change. They're only dependent on the sliders. They're not dependent on the audio or in any other kind of user interaction. So we can pre-compute all the positions. We already did that in the slider block. Now in the GFX block, all we have to do is traverse this positions array. We go over the positions array and we draw the curve on the screen. So the first line is pretty straightforward. I'm just defining the stroke width, the width of the line that I'm going to draw. And then we have another loop. And in this situation, the loop is not looping over the positions array. No, it is. Yeah. Can you show me the last portion of the GFX block? Yeah. So, yeah, before I even do the loop, I have to do something that is similar to our time increment that I had before. The time increment I had before was so that I could simulate the ball position over time. And now I have to draw this on the screen. So I have more positions than I have pixels on the screen, hopefully. Because if I don't, then you will see gaps in the drawing.
Yeah.
So what I do is define this X increment, which is how much to the right do I have to go to keep drawing the next pixel. And I have stored 5,120 positions in the position array, right? So what I do is just, I take my screen width and divide by that number. So I know that I'm going to draw each one of the positions. By the end, I will have reached the right of the screen. So then on the next line, I set up a loop. similar to all the other loops, I am just going to loop over all the positions in the array, but I have two variables to keep track of. One is pretty straightforward, that's the positions index. It's going from 0 up to the size of the positions array.
Yeah.
The second variable is not so straightforward. That's the x position. So what I started with 0, which I think is probably incorrect. It should probably start with minus x increment, shouldn't it? So that the first time you go around the loop, it is actually going to be 0 the first time, right? So can you change that 0 to minus x increment, please?
Oops.
And yeah, while you were doing that.
Hi, Jim.
Hey, and Bo is asking if you have COVID, and Arya promised that he probably does not.
Yeah, yeah, probably not COVID, probably something else. It's funny because the other day I was thinking to myself, damn, I'm so cool, I didn't get COVID. Because it's nice if you're one of the people on the planet who didn't get COVID. Though percentage-wise, like, you're likely to be not getting it versus getting it. But I jinxed it. So it could be, I don't know. We'll see. Anything could be COVID.
Yeah. Right. So what we're doing is we're traversing the positions array where we have already stored the positions. And we are just going to draw that on the screen by first fetching the particular position at the index that we are at. So that's why you see positions at data at positions index. And then to calculate the y position, the x position is already taken care of, right? We already set the x position based on the x increment. So that's fine. The y position is based on the position that we calculated before. And we divide by 2 because at most we have 2 meters. That's the maximum of the slider. You can see right now, Arya put the slider all the way to the right, and that's 2 meters. So that's why I divide position by 2. Then I multiply by the height of the whole window. So this is going to be a number. So think about it this way. Position is going to be a number between 0 and 2. Why? Because at most you're going to let the ball go at 2 meters.
Yeah.
And the desk is at 0 and we don't go below the desk. So position is a number between 0 and 2. When I divide that by 2, I have a number between 0 and 1.
Yeah.
When I multiply by GFX height, I have a number between 0 and the height of the window. Mm-hmm. But we are working with a coordinate system where y equals 0 is the desk, so that's the bottom, and then positive values go up. But in the drawing window in GFX, the coordinate system is upside down. Y equals 0 is the top, and positive numbers go down. So that's why we say GFX height minus the height that we just computed. And that's our y position. Then we draw a rectangle on the given x, y positions, and we draw a square of the stroke width. So if we draw enough squares next to one another, it resembles a line. That's what I did. That was my part of the homework.
That's awesome. Bravo. I saw something that I thought actually looks cool, but I'm trying to recreate it. I'm not able to. At one point, I did something. I played with some number, and I could actually see these kind of more like balls. Like I could see this wasn't like a line. It was like circle, 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 and that looked really cool actually. It looked like a ball, but I don't know what I did or how I did it because I was.
Yeah, let's explore this thought in the sliders that we currently have on the screen because they're super cool. I mean, it's super cool that you can change the sliders and you see the curve changing in real time. So first of all, the height is pretty straightforward. It's going to determine where you let the ball go from.
Yeah.
The gravity is going to change something. So play around with the gravity.
Yeah.
See, it's cool that it's changing from left to right, but it's not changing up and down.
Yeah.
Isn't that interesting?
Yeah. Oh, there we go. Yeah. Now it looks like balls kind of in some places.
You can start to see the squares because I don't have
Yeah.
enough squares to draw this line. And you can start seeing a bit of the squares. And that's fine because eventually we are going to draw this differently. So it's not going to be a line. It's going to be a sound wave going through the motions, right?
So I guess I have a question here. Since this is time, right? So when we change the gravity, when we increase the gravity, sure, then this time between these is gonna go down. And not that I care about this too much, but I guess if gravity was more, these bounce ups will also change, but they don't change.
That's the interesting part. It's one of those counterintuitive things about gravity. The thing is, with a gravity that is stronger
Yeah.
than Earth's gravity, not only you are going to hit the desk faster because the acceleration is greater, so your velocity is going to increase faster and your position is going to go faster. In fact, it's going to go so fast that you start seeing the little squares I used to draw the curve. So if the gravity is stronger and you're moving faster, you're not only moving faster, but you are going with a higher velocity.
Yeah.
So when you bounce back and you lose some of the velocity, you lost some of a higher velocity. And everything is proportional.
Cool.
So you end up going up the same amount. So that's why the bounces, the little curves, move left and right because they're happening sooner or later.
Yeah.
But they don't change in height because the gravity is the same. So you're hitting the desk with a higher velocity and you are losing a little bit of it, but it's going to compensate for the. So you are hitting the desk with a higher velocity. So you're going to bounce back with a higher velocity to work against the stronger gravity. The higher velocity is going to work against the higher gravity, and they're going to cancel out.
Gotcha. Cool. Very cool.
Isn't that fun?
Yeah.
Yeah. So in essence, the gravity is like the length of the tap.
Yeah.
And then the elasticity is how much of the energy is going to be used to bounce back. And then when you change the elasticity, you see a change in height.
Yes. Let me demonstrate that one more time. So if there's no elasticity, I mean, the ball drops and goodbye. And then little bit. And if the elasticity is like at 99, we're losing a little bit, but not too much.
Yeah, and the other interesting thing about the elasticity is that it changes the height, but it also changes the time.
Changes the height, but we would expect that, right? Because the more elastic it is, the more it's gonna bounce back up.
Yes.
I don't know if that's the best way to reason about it, because also it's like about how much of the energy is lost in sound. But in any event, we haven't really done that bit of the thing. Like we're just doing like despite how complicated this is, we're doing a simplified version of it, of this, not like super physical when it comes to what decay. So I have a question now. Actually, it's not really a question. Do you wanna listen to it?
Yes. Yeah.
Okay. Because I figured out a couple of things about this. So let me kind of find my way here. Oh, this is our thingamajig. I'm just gonna move this forward a little bit. And why is it on the ball drop track? It should be on here. Wait, that only goes to rear delay, doesn't go to ball drop. Well, we want you to go to ball drop. Or actually, I'll just put it on the ball drop track. That was correct. Okay, first of all, wow, that sounds awesome. I was really brave and I forgot to mute to test, but luckily nothing bad happened. So I figured out why the first bounce is incorrect. And the reason is, like in my when I was doing this on rear delay, okay. On rear delay, I have like a bunch of taps, and they go up in increment from each other, which is very kind of inflexible. But anyway, that's what I had. The way I was seeing it was that my dry sound is the first, and then the rest are generated by up to 9 taps, so for a total of 10 taps. However, in our thing, when the dry sound hits, the dry sound is kind of here. So then it very quickly falls to the first place, and then it's linear. But really, like, what should happen is that, like, the first transient is the drop here, and then it goes around and round to doing the rest of the stuff. But yeah, this first kind of like traversing, this first traversal is going to be shorter because it is just from a height to 0, and for all the rest is from 0 to a maximum height that it reaches and back to 0.
I see. So I can think of some different ways of solving this. What ideas do you have for fixing it?
So I guess, yeah, my first idea would be, okay, yeah. I guess my first idea would be that kind of our GFX starts from here. And if we adjust the height, we can see the effect of that on the subsequent bounces. You know what I mean? So just basically, this is the problem, just cutting out that bit from the code. But I don't know, does that work?
Yeah, I can see some solutions. I can see us just muting the dry signal, and then all you hear is the delayed sound. Or we can adjust the timing of everything so that the dry is the first bounce.
Oops, sorry, I should have done that.
That's okay, you have a limiter on.
Yeah, I guess. But Cause I did try that. I did try, how did I try it? How did I try that thing? So I guess, yeah, I guess the issue with just killing the dry and just showing the wet is that it'll be delayed by kind of an arbitrary amount.
Yes.
Yeah.
And that can be a bad thing if you're trying to do something more rhythmic, or it can be a good thing if you're doing like a pad.
Yeah.
It doesn't really matter the timing all that much on a pad. In fact, I think it would be fun if you could quickly route some sounds, some
sure
synth or a guitar or something.
Sure.
Did you try to actually play with this to see?
Well, I've played with this. Yeah, I've played with this cause I had like a version of it. But yeah, sure. Let's give that a go. I'm gonna do it like this. Let's choose a fun. Whoopsie daisy. Let's choose a fun sound. I just got these sounds on Labs that I really think sound awesome. and they are the categorization of labs is shit. Fix your crap there, labs. I know it's free, but I'm accustomed to a certain quality of life. Lab steel. No, it's not even the lab steel. It's like, come on.
Did you install every single lab?
More or less, yeah. Oh, guitar harmonics. That's the good stuff. That's not the one I wanted. Yeah, that's the stuff right there.
Not too bad.
Yeah, not at all. Bad at all. Not bad. Not bad at all. I can't fucking speak anymore. All right. I guess I didn't pick a good sound. I should pick a sound that's really kind of upfront and not a lot of sustain on that. But whatever, let's just keep using this sound. And then gravity, let's... Yeah, let's just crank it, whatever.
There is something weird with the loudness as well, right?
Yeah.
The first one is super loud.
Yeah. And then every once in a while, some of them are really loud. Yes, at one point, well, okay, actually, wait. Some of my, I'm going to put it to exactly the thing that I did, that I got something out of. Yeah, that's the good. Or actually, random divider may have been just on 2. Yeah, so these were the settings that I found that were really cool.
Right, we should make them defaults, or maybe even get rid of the random divider.
Right, yeah, we were just trying to figure out the number, and I think... So now I want to try one more thing, and that is... if I go pre-fader and I turn this off, now it will sound exactly like the ping pong ball. No, oh, cause now we didn't hear the dry from my sound, but we still hear a dry out of the ball drop. Whoopsie daisy.
Yes.
And then I guess the question becomes, can I just make this shorter? Cool. Awesome. Yeah. So I think, yeah, from the defaults, the only thing that we need to change the default of is elasticity. I think 891 is the good stuff. And
it doesn't seem like elasticity should have such a huge range, right? It should be more between like 0.8 and 0.95 or something.
I mean, okay, so let's look at like 495. I mean, I think this totally has its uses, because then this is like within half a measure. Like,
okay.
You know what I mean? Even like, but I mean, I don't know how much we can manipulate this. I guess we can't really manipulate this. Yeah, like if it was a way for when the elasticity is really low, for it to be more like self-oscillation, so it goes bring, ring, something like that, that would be a whole other sound. But I think like, yeah, 297. That's totally like musically usable to me.
So let's go from 0.3 to 0.9. How about that?
Yeah.
Okay.
Actually, maybe because okay, so then if you make it 1, that's cool, no? Oh, we can't make it 9, but it's very perpetual.
If you make it 1, it's gonna feedback forever.
Yeah. Yep. All right, let's cut this out. But yes, which I mean, to me, even that is not something I'm against.
Looping forever?
Yeah.
Okay.
But it probably is kind of crazy. I mean, 0.99 already loops for a really long time, so so yeah, let's do that.
Well, it at most it's gonna loop for 20 seconds.
Oh, okay, because that's how much sound we have. Cool.
Yes, we in a true feedback in a delay. So there is something to be said about this because it's kind of deep and counterintuitive and interesting. In a feedback parameter in a delay, it makes the sound going out go back into the input.
Yeah.
That's not at all what we are doing. We just have more taps along the way. So if you try to do something that is going to sound forever, it's not going to sound forever. It's going to sound for 20 seconds and it's going to stop immediately.
Oh, sorry. I just noticed Fotis' message about my ReaFIR. Yeah, that's very possible. I screwed something up with ReaFIR, and Leandro has to help me one day to make my ReaFIR work again. I thought I changed the main to master. I shouldn't have done that. Now everything is like half there and half not. It's a whole clusterfuck. So we'll do that.
Yeah. I went through the same. I updated the name, and then everyone complained that the repack was down, and it sort of was. But yeah.
Yeah.
In any case, yeah. Hey, Fatis, great to have you here.
Sorry, I got totally distracted by that comment. So what did you say before that?
I was saying that there is a distinction between elasticity of one and a feedback in regular delays. Feedback is taking the output of the delay and feeding it back into the input.
Yeah.
So if you make any sound and you have a feedback of 100%, it's going to loop forever.
Yeah.
But in our thing, the elasticity is just determining that we need to have more taps.
Yeah.
And our delay line needs to be of a fixed size.
Yeah.
It is 20 seconds right now. So if you set an elasticity of 1 and you make a sound, it's going to keep sounding for 20 seconds and then immediately stop.
Yeah. It's also funny. Oh, sorry. It's also interesting. And that's what we wanted, right? We didn't want the taps. We didn't want the timing of the taps to affect each other. And I think... Let's try it. And I'm getting really cocky not muting the master.
Recipe for disaster.
Yeah. So we can actually automate our delays, like timing-based parameters, without the length of the delay buffer changing, affecting pitch or affecting pitch. You know what I mean? So one issue that I had with every other delay when I was implementing this was that I had to have discrete taps. Otherwise, they would feed into each other. And as I changed the timing, it would change the pitch. So yay.
Yeah, usually it is more work to make the pitch change. But in this case, I guess it's not desirable. So we are fine. Making the pitch change is actually kind of fun, but I don't think we're going to tackle that. And there is something to be said about automating the gravity or automating the elasticity or even automating the height, anything that is going to change the taps. Because Right now, we are storing a bunch of samples, and in our tabs, we are just getting one of the samples, or for each tab, we get one of the samples that we collected. But to be even more accurate, what we should be doing is having something called interpolation of samples. So if we detect that the time or the sample that we need to collect is like sample 2.5, that's our tab.
Yeah.
It's sample 2.5. Right now, what we are doing is saying, okay, if it's sample 2.5, I'm going to get sample 2.
Yeah.
Or I'm going to get sample 3. But right now we are getting sample 2. What we should be doing instead is calculating what would the sample be at position 2.5. And there are several ways of interpolating samples to get that precise value. And if we wanted to automate this parameter or even to make it change in pitch, definitely that would be the first step, to interpolate and get those samples in the middle.
Cool. Jim is
But let's
saying
not worry about
also
that right
adding
now.
a control to soften the attack. Yeah, that would be cool.
What would that sound like or look like? I don't really understand it.
So I guess like one thing we're toying with, we haven't, I don't think we've integrated this, but was to be like maybe just a basic kind of low pass filter or high pass filter or both would be applied to every new tap. So I guess, yeah, if we were to soften the attack, well, I don't know how that would work in the context of a delay, but yeah, I mean, essentially, right? If we just implement a low pass, that's gonna soften the attack a little bit.
I see.
Yeah.
But it's more of an EQ kind of thing than when I think of softening the attack, I think of compressors.
Yeah. So I was thinking.
But I don't think that's the case.
No, I think, yeah, well, compressors is the best way to do it, but that would mean like implementing a whole compressor into this shebang. But just kind of like a simple way of like softening something. Cause transients kind of, like if you have a drum, if you have a tom or something, the transient really kind of spreads the entire spectrum. Then it evens out into like a single tone. So a low pass would mean some of the transient material goes away.
I see. Can you like maybe take notes of these ideas?
I did, yeah. I added that.
Okay, great. Great. So now we have the problem of the first sound, the dry sound. Do you want to let the dry sound through, or do you want to shift the timing of the whole thing so that the first bounce is the dry sound?
Yeah, that would, I think, like at least for my brain, that would work better, is the latter option.
Okay, so to make that happen, we have to revisit where we are computing the tabs, I think.
Yes.
Yes. So right there, where you are not in the sample block, but in the slider block where you are computing all of this tabs array, we are looping over the tabs array here. Can you go to the slider block?
Oh, slider block, sorry. There it is. Yep.
Yeah, so we have this data storage loops kind of thing where we are computing where the tabs should happen.
Yep.
Right?
Yep.
So let's review how we are doing this. Okay. All right. So I guess there is a kind of a hack that can work. Right now, what we're doing is we're computing the bounce times faithfully according to that figure that we are drawing in the GFX block. And the key variable here is the bounce time in seconds.
Yeah.
We are computing the first bounce time in seconds 2 lines above where your cursor is right now. And that's our initial bounce.
Yeah.
So before, what we were doing was mixing the dry signal into this first bounce. But that's the problem, right?
Yeah.
So I guess what we can do is, before we go into the loop,
Yeah.
we set the bounce time in seconds to 0. We still need to compute the lines that are on the code right now need to be there because we need to compute the velocity,
Yeah.
the initial velocity of the first bounce. So that needs to be there. And the bounce time in seconds is used to compute the velocity. So all of that stays, but right below the line that reads steps computation, the comment,
Yeah.
you can say bounce time in seconds equals to 0.
So.
And before we get into the loop.
So wait, change this to 0 or make a new line here?
Make a new line.
Okay. And then go whoopsie daisy equals to 0.
Yeah, so now we are resetting the bounce time in seconds.
Cool.
And you can see that when we update the bounce time in seconds on the third to last line in the loop, we are just plus equals something, right? So we are now, by using this trick of, it's kind of a hack, but with this hack, we are pushing everything forward.
Yeah.
Or we are making everything happen sooner. Because we are decreasing the time of the bounce time in seconds. So that's part 1 of the hack. Part 2 of the hack needs to happen below in the sample block, where we mix in the dry signal with all the taps. Now the first step is actually the dry signal.
Yes.
So you can just not plus equals.
Here?
Or better yet, before you start that loop, so there is a line that reads circular buffer.push.
Yep.
So in that line, after that line, let's zero out the channel. Zero out the sample in this channel. And the effect that that has is to mute the dry signal.
So I have to add a new line, right?
Yes, add a new line there that reads SPL of channel equals 0. That is going to remove the dry signal, but that's all right because right after we are going to use all the taps, and the first step is the dry signal. So let's try that.
Save it, full recompile and reset it, close it. I'm even gonna delete it, add it again. Now that's exactly the sound of a ping pong ball.
It is. Right, yeah. And Bo says that we could use Fft blurring and more stereo panning on the taps as they go. Is that something that is on the list of things to do?
Now I no longer care what people say. I'm so happy. No, we haven't talked about Fft blurring. I'll add it.
Yeah, let's add that to the list, and then at some point I will learn how to do it, and we can do it.
I mean, that's the stuff. Like, that's the stuff.
No, save this. Yeah,
I saved it.
Yeah, don't lose this stuff.
No, the only thing we would have lost was the note anyway, but yes.
Yeah, sure. Because the effect is running, so you must have saved.
I can totally... this is great. Okay, awesome. So...
I'm happy that this is making you so happy.
Yeah. Also, I guess let's stop in 25 minutes just because I thought, well, I'm sick. I can still stream, but really I can't. Something in my eye is like burning. I don't even know if that's part of the illness or what.
So Let's call it a day then.
We'll call it a day at 3 my time, which is 9 your time, right?
Okay. I thought you wanted to go. Hang in there. Time zones are difficult. So
Whatever's
you're
in 23
saying 3
minutes.
p.m. Okay. So it's 8 UTC.
Oh, okay, 8. Sorry, yeah.
All right. So we have 23 minutes to go.
Yeah.
And I thought we could do something on that visualization that we want to have with the sound bouncing.
Yeah.
So to do that, first we have to store samples.
Yeah.
But that's actually something that we are already doing. We have a freaking delay line.
Yeah.
Right? So that's easy. Now in the JSFX block, we need to access that and we need to draw that waveform.
Sorry.
I'm thinking that maybe it could be a nice start for us to just literally draw that on the screen.
Okay.
Yeah. So how about this? We start by drawing it as a straight line. Then we draw it following the curve.
Yeah.
And then finally we rotate it so that it is following the path.
Mm-hmm.
Does that make sense?
Yeah.
Okay. So
I guess go to the code.
yes, we need to go to the JSFX block. And I think that maybe the best way for me to do this instead of trying to dictate code to you is, can you pull in the code share thing?
Sure.
Yeah.
Group. I'll make it a little smaller because this is crazy.
Yeah, and I think that in 20 minutes we might just be able to draw it on the screen.
Cool.
And that's all right.
Cool.
So we do have a loop that, we do have a delay line that has all the samples we collected.
Yeah.
So now we need to go over the delay line.
Do you want me to paste all the code once again on the code share?
No, I have it here and it is on your screen, so it's fine. Oh, yeah, but people were not seeing the code, so maybe you want to split the screen so people can see the code.
All right. Joops. And you get out of here for now. And Joops. And Joops. And maybe make this bit small. And maybe do this so that your face is not in front of it. Or I'll actually do this. Joops. And I'll do this. Joops. All right. Cool.
Right. So first thing is, we don't have a single delay line. We have one delay line per channel. You can see in the sample block that we are doing a loop over every channel. And we do have to do a loop just like that, except that if we use the variable name channel on this one, remember that the sample block and the JSFX block run at the same time. So that's not good. Instead, I'm going to do something that I am doing now on my library all over the place, and that is to use a namespace. So this is something that is going to go in the JSFX block. I namespace that with JSFX channel. And then the rest of the loop structure is what we are already used to, and we need to go over the number of channels.
This is for Jim.
The dissonant.
I can't even go more dissonant. I can play a tone cluster. I can play a flat 9. Back to the code.
Right. So what do I want to do every time I go over all the channels. Well, I want to do a block that is essentially the block that we currently have on the GFX code.
Yeah.
I just copy and paste it from there.
Okay.
So I'm just looping over all the positions
Yep.
in that path that we computed. Well, in fact, I think that's going to be part 2, right? When we actually try to follow the curve. So let's do something else instead.
We just want to draw
Let's
now.
do something like sample index.
So sorry,
equals
before you go on, so GFX chat, that first line that you have on Culture looks a lot like when we are trying to make something multi-channel, but it's a GFX. So what's up with that?
Well, my idea is that we want to draw the waveforms for all the channels.
Oh, okay, there we go. Gotcha.
Yeah. And I thought we could even draw them all stacked with different colors, maybe, something like that.
Okay, cool.
Yeah, so now let's go over the samples in the delay line. Yeah, so we first need to get a hold of the delay line. So let's write a line that is similar to the first line in the loop in the sample block, except that, again, I cannot use just delay line because delay line is already a variable. So I will use GFX delay line is equal to delay lines at the GFX channel.
Cool. Whoops, sorry.
And delay lines is a variable that needs to be the same everywhere. It is shared between the sample block and the GFX block. So that's why we have it this way. So that's the delay line that we have for the current channel. Then let's go over all the samples in that delay line. So I'll call this the sample index. And I'm going to start with 1, and I'm going to loop over. And I need here to loop over all the samples in the delay line. So I need to get a hold of the size of the delay line. And it goes like this. Maybe I'll have something like this to help me out. And to fill in this line, I will have to dive into my library real quick because I don't remember all the names of everything. So there is this thing here on a delay line, which is a circular buffer. I can use this to get a hold of the signal, and the signal is an array. So I can use something like that to get a hold of its size. Oh, I should have it here. Like this. So now I'm getting the size of the delay line by diving into, come on, help me out here, cursor. Great. So I'm going into the delay line. I'm getting a hold of the signal that is in there and then of its size. So essentially, this line is going to be like the number of samples that corresponds to 20,000 milliseconds, to 20 seconds, in your current frame sampling rate. Then on this next line, I'm setting up the loop. So I'm going to go from index equals 1 and minus 1. And you may be wondering, what's up with that? Well, in a delay line, we don't have a base address and we go forward. So usually when we are doing loops like this loop, we start with position 0 and we go to positive numbers.
Yeah.
But in this case, in the delay line, we go to samples in the past.
Right.
So that's why the index is going to negative numbers.
Cool.
Then, to get a hold of a sample, I am going to go into the delay line. And I have a method for this, actually. So let me get into my library real quick. And
meanwhile, I'm going to show Bo vocal samples because he asked. So here's some vocal samples. Whoa. course, it clicked a little bit, so I'm gonna just make it a little zoopsy zoopsy. Let's try one more time. Hooray, so easy. There you go. That's that.
Right. So the loop that we currently have is going from samples from the most recent into the past. That's why the offsets, I changed the name from index to offset. That's why the offsets are negative. And similarly, I want to go in the user interface on the x-axis, I want to go from right to left. So I'm going to set up our x equals to GFX width. So it's at the rightmost position of the screen. And I'm going to keep this x around along with the rest of the loop. And that's why I'm putting everything in a single line. So all the variables that are affected by the loop logic are going to be on this line. And you may want to change this later if you don't feel like that's a good thing. So
speaking of change, I had another question for you. Say once we do all this code, if we decide, okay, instead of a 20-second buffer, we want a 60-second buffer. That's easy, right? We just change that number, we get 60 seconds of delays.
Yes.
Cool. Okay. Sorry. Totally off topic.
Yeah. And the bigger that number is, the more CPU you will need to use. Right. Okay. So then we are going over the delay line. Oh, there is actually an issue here, isn't there? Yes, there is an issue. I am going over the delay line, which is in samples, but I am going with the X thing over positions. I'm going to go over positions, right? So I need to have another loop, actually. Let me just copy and paste the loop that we currently have on the code, because that's a good setup. So we have a positions index equals -1, and then we start with x equals 0. Well, that's my old version of the code. It is supposed to be x increment. Yeah, so that's the loop that we currently have on the code, and it's going over positions. That's great. So how about I make it go from right to left? To make it go from right to left, I will change this. Maybe for the stream, it's better if I put this in multiple lines, even though that's not my usual style.
Yeah, I'm always a fan of different lines.
Like this. Yeah. So right now, we are looping over all the channels. For each channel, we are getting all the positions that we computed, the positions of the ball on the screen. And no, I think I know I'm going back and forth here, but this is going to be step 2. Step 2 is going to be to put positions on the screen. So let's continue with this idea. Going over all the samples that we have collected, we start on the right of the screen, and then we need to decrement some x decrement, and that is going to be the width of the screen divided by the number of samples that we have. Just like that. And then we get a hold of the sample, and we are ready to start trying to draw that sample. Let's use a rectangle. And we do have a variable for stroke width, so I'm going to keep that. Or maybe I will do something thinner, because this is a waveform. It has many points. So I'm going to start with 1, 1, but I may increase or decrease this number later. Well, not decrease. I can only increase from here. Right, so Then the X position is something that we have already computed. And the Y position we still have to compute. It's going to be a similar trick to what we used before. So I'm going to copy and paste that line and we can change it. So we go from the height and then we go to minus. In this case, it's not position divided by 2. It is that. And our samples can go from -1 to 1. So how about we start in the middle of the screen and then we go we go up and down by half of the height.
Okay, sounds good.
So if we have a sample of 1, then this is going to be half of the height, and half of the height minus half of the height is going to be the top. And if we have a position of a sample of -1, that is going to be plus half of the height, and half of the height plus half of the height is going to be the full height. So we go to the bottom.
So these two things are gonna be both happening on. I guess let's just look at it.
Can you like copy and paste this and try it out?
Yeah.
You just have to paste it at the end of what we currently have.
In the goofs block.
Yes.
And I'm gonna give it a name like drawing of the waves. And do that and do a full recompile. Okay, so you created a new window. I was wondering about that. I was like, are they gonna be on? It'd be cool if they're on top of each other, you know, because there's all this like space here. So what if the waves were drawn there? But let us check this out. I should send the sound through, right?
Yeah, if you send any sound through, then we should see the sound being drawn.
Wow, beautiful.
Great.
Well, but
that's good
it showed us only 2 of them.
And that's weird, right? It should be showing only 1.
Oh, okay.
Because we are only rendering the input, the dry signal. The dry signal is moving through.
Well, let me try again. I may have hit space twice. It's also very slow now. No, it's drawing twice.
Yes. Yeah, we are doing lots of things that are super slow in this loop.
All right. Back to the code or back to CodeShare.
Yeah, so drawing the thing on the screen was step 1, drawing it over the line was step 2, and step 3 was making it rotate on the plane. But we only have 5 minutes, so I think it's time to say goodbye.
Okay, yeah. Sorry, everybody. I thought I can stream because I'm not going out, but I don't know. I'm just kind of coughing and sneezing here and dying over here. So, I don't know. I wish I had a video ready to go, but I don't. And on Wednesday, we were gonna not stream anyway with Leandro, so that's not happening. If I feel better by then, I may do another one of my mixing live streams. And so let me just see if anybody said anything new. No. Leandro, any last words?
Yes, tomorrow I will be doing Arduino stuff. I got all the parts I needed. So tomorrow it's Arduino time on my channel. We'll be continuing the homemade MIDI controller.
Fun. Well, since I'm assuming that I won't be going to work tomorrow, I will be there. I feel very lost. I feel like I'm not your library. I'm no longer in the loop about it. But yeah, so that should be fun. Thank you as always, Leandro, for all your help. Yeah, one day maybe you can help me with my ReaFIR thing.
Sure.
Yeah.
Yeah.
It's a mess, and I haven't even been adding new actions to it, even though I've been making new scripts that I'm very proud of. So, yep, help is appreciated. Thank you, Jim. Thank you, Bo, 40-cent stuff, Vertigo Pulse, other people who lurk. Thank you all for being here. Yep, wish me well. And I will see you probably on Wednesday, but no promises.
And I see you tomorrow. All right, bye.